So get ready, because today we're going to completely shatter your perception of physical reality. Like literally. If you look around the room right now, you see solid objects, right? Tables, chairs, walls. But what if I told you that fundamentally none of that actually exists in the way you think it does? Today, we are going on a total mind-bending descent into the quantum realm. We're going to be using some absolutely incredible insights from a recent discussion between astrophysicist Neil deGrasse Tyson and theoretical physicist Sean Carroll. We're going to break down the actual, literal fabric of reality, step by step.
Welcome to our channel, where we explore the darkest corners of the cosmos, the mysteries, the threats, the unknown. This is space like you've never seen
Okay,
it before.
let's dive into this with what honestly sounds like a ridiculous question. Do electrons actually exist? Because here's a totally wild fact for you. Physicists have never actually measured the physical size of an electron. No way, right? But it's true. It is smaller than the smallest capacity we have ever conjured to measure it. So you have to ask, does it even have a size? Or is the whole thing just a complete illusion? Well, in their conversation, Sean Carroll makes this brilliant pivot when asked this exact question. He says, physicists often tell a little lie to keep beginners comfortable. And the lie is that the particle is what's real. But the actual mind-bending truth that the experts discuss in the back room, what is actually real, is the electron field.
So here's our roadmap for making sense of all this madness. 1. Particles are a lie. 2. Reality is a wave function. 3. Demystifying quantum entanglement. 4. Schrodinger's cat and many worlds. And 5. Quantum effects you can see. All right, moving right along to section 1, particles are a lie. So if we rewind a bit to 1895, the classical Newtonian worldview was honestly pretty intuitive. The universe was made of matter. You can think of particles as these solid little billiard balls making up tables and chairs, and then there were forces, right? Things like gravity or magnetic fields acting on those balls. But the great triumph of quantum physics in the 1920s revealed that everything, and I mean everything, even electrons, quarks, and neutrinos, are actually just fields. It's vibrating fields all the way down. So the absolutely crucial point here is this. A particle is just a highly localized vibration within an underlying universal field. And this brilliantly illustrates the quantum illusion. See, we haven't failed to measure an electron's size because our tools are bad. We haven't measured it because, well, the electron simply doesn't have a size until we interact with its field. When our detectors ping that field, it pops up. It appears to us as a solid particle. But when we aren't looking, it's just a spread out wave.
Which brings us to section 2. Reality is a wave function. Now, if particles are just fields, how do they connect? You might think that every single field or particle has its own separate isolated wave function. But Sean Carroll injects so much enthusiasm into this realization, they don't. He says there is just one wave function for the whole kit and caboodle. Every particle, every field, you, me, the stars, they are all mathematically combined into a single universal quantum state. That is what's real.
And this brings us to a concept physicists call a Hilbert space. It's essentially the mathematical space of all imaginable quantum states of the universe. Now, sure, physicists love to debate interpretations here, but purists view the actual physical universe as literally just one mathematical vector within this Hilbert space, and it's constantly changing with time. That mathematical vector, that is reality.
Okay, moving on to section 3, demystifying quantum entanglement.
Now, what's really interesting about this concept is how it dismantles the sci-fi hype. Entanglement simply happens when two objects interact and share a combined wave function. So for instance, let's say a Higgs boson decays into an electron and a positron, and they fly off in opposite directions. Because of the laws of physics, momentum has to be conserved. So the very moment you measure one particle and find out which direction it's going, you instantly know the exact status and direction of the other one. It's not magic. It's definitely not mystical teleportation. It's just that they are part of the exact same underlying mathematical state.
There is this massive misconception out there that moving these particles physically far apart magically breaks the entanglement. Actually, scratch that. It doesn't break it at all. Physical distance does not matter to the laws of quantum mechanics. The only reason distance is a problem is that the further apart they get, the higher the chance one of these super fragile particles bumps into a stray photon or some heat radiation.
and decoheres, which basically just means it gets messed up by the environment. It is purely a technology and engineering problem. It's not a violation of physics. And to prove this, researchers in China recently managed to entangle particles across a 50-kilometer fiber optic network. I mean, that's essentially the size of a whole city. The ultimate goal here is to eventually create a completely secure, unhackable quantum internet. Now, for sure, it is an immense engineering challenge requiring ridiculously cold temperatures to keep those stray photons away, but the math absolutely works. Let's shift gears to section 4, Schrödinger's cat and many worlds. So, Erwin Schrödinger originally proposed this famous thought experiment with a cat in a box, where a randomized quantum event, like a decaying radioactive particle, triggers a release of gas. Now, Sean Carroll prefers a much more animal-friendly version where the cat just goes to sleep, which I think we can all appreciate. But here's the core logic. Before you open that box, the radioactive particle is in a superposition of both decayed and not decayed. This means the cat is simultaneously in a state of being awake, running around the box, and asleep, snoring peacefully on the floor. Everything inside that box, the air, the light, entangles with the cat and enters a superposition of two completely different, simultaneous physical states.
Now, we need to pause here to impartially clear something up, because you'll often hear this popular New Age trope that human consciousness or some kind of brain energy is what collapses these quantum states and brings reality into existence just by looking at it. According to the actual physics in our source material, this is completely false. In physics, an observation is not a conscious entity. Just shining a light on a particle or having a single stray photon bounce off the cat, that counts as an interaction. The environment itself is constantly measuring and localizing things all on its own.
So what actually happens when we open the box? Well, back in the 1950s, a physicist named Hugh Everett suggested this radical solution called the many worlds interpretation. He argued that all quantum probabilities are physically real. So the moment the box's contents entangle, the universe literally splits. There is one real physical universe where you open the box and see an awake cat, and a completely separate, non-interacting universe where you open the box and see a sleeping cat. The worlds aren't located in space. Space is located within each world. It is, honestly, a staggering concept. Let's move to section 5, quantum effects you can see. Let's see how this all builds into the macroscopic reality we experience every single day. 14 billion years ago, right after the Big Bang, the universe underwent rapid inflation. It was expanding incredibly fast, kind of like smoothing out a wildly wrinkled bedsheet. But quantum mechanics got in the way of it being perfectly smooth. Tiny quantum mechanical uncertainties during that fraction of a second created little microscopic ripples in the energy of the early universe. And over the next 13 billion years, gravity pulled matter right into those tiny ripples, eventually forming the stars and galaxies we see today. And the crazy part? We can actually see the fingerprint of this today. When we look at the cosmic microwave background, which is the relic radiation from the Big Bang, the temperature is uniform across the entire sky to within 1 part in 100,000. It's almost perfectly smooth. But those tiny 1 in 100,000 variations, those are the direct visible result of quantum fluctuations. Without those early quantum ripples, matter just wouldn't have clumped together, and we literally wouldn't even be here to talk about it. And, quantum effects are even closer to home than the distant stars. Think about that cartoon image of an atom you learned about in high school. A nucleus in the middle with electrons orbiting around it like tiny planets in a little solar system. That is a lie. If atoms were just empty solar systems, matter would easily squish together. The truth is that electrons are not point particles, they are spread out wave functions that take up actual physical space.
So the only reason you don't fall right through the floor, and the only reason the chair you might be sitting on right now is solid, is purely because of quantum mechanics. Those spread out electron wave functions in the chair's atoms, they absolutely refuse to overlap with the electron wave functions in your body. The solidity of the everyday world is a direct, tangible result of these fields repelling each other.
Neil deGrasse Tyson sums up this entire journey beautifully. He says, the universe is under no obligation to make sense to us, but remarkably, it keeps making sense. It's so true. Our everyday human intuition just fails spectacularly when we look at the quantum level. But by updating our models and following the math, even when it leads us to crazy things like vibrating fields and multiple universes, we gain the ability to truly comprehend the breathtaking mechanics of the cosmos. We've covered a lot of ground today in this explainer, from debunking particles to exploring the very foundation of the universe itself. But I want to leave you with one final provocative thought. If everything in reality, every particle, every field, your brain, your body, if it is all fundamentally just a single mathematical vector changing in a Hilbert space, what does that make your conscious choices right now? Do we actually have free will, or are we simply the universe playing out its single massive wave function? Something to think about. Keep questioning and keep looking up.
If this video made you think, hit like, share it, and subscribe to this channel. Because the next mystery is even deeper. Until then, stay curious.